Let's continue on Systems Analysis and Design with Chapter 6. This is Object Modeling. The career objectives. Explain how object-oriented analysis can be used to describe an information system. Define object modeling terms and concepts, including objects, attributes, methods, messages, classes, and instances. Explain the relationship among objects and the concept of inheritance. Draw an object relationship diagram. Describe UML, or Unified Modeling Language, tools and techniques. Include use cases, use diagrams, class diagrams, sequence diagrams, state transition diagrams, and activity diagrams. Explain the advantages of using case tools in developing the object model. Explain how to organize an object model. OO analysis, or object-oriented analysis, describes an information system by identifying things called objects that represent people, places, events, or transactions. OO methodology is popular because it integrates easily with object-oriented programming, like we've mentioned, C++, Java, Smalltalk, VB, Perl, and Python. Programmers also like OO code because it is modular, reusable, and easy to maintain. We're going to see some examples of this as we go ahead, and I'll try and explain some of this from a programming perspective as well. Object-oriented terms and concepts. UML, or Unified Markup Modeling Language, is the method of visualizing and documenting an IS system, or an IT system. Attributes are characteristics that describe an object. Methods are tasks or functions that the object performs. A message is a command to perform a method. A class is a group of similar objects. An instance is a specific member of a class. So when we think of this, I always use the clock example. This book uses something different. It does a good job of explaining it. Here we have an example of objects. In this we have two objects. We have the driver object and the car object. Objects represented as a rectangle with an object name followed by the attributes and then the methods. So you don't really see that right here, but you will. So here we show that the driver has attributes including license number, age, maybe gender, could be address. There's all kinds of attributes associated with the driver. Car could be year, make, model, VIN, color, all kinds of stuff. Here is an example of parent objects, and here we can see the attributes and methods associated with it. So it's represented in a box like we said. So the characteristics or attributes are items that describe the object. So you got name, age, sex, hair color. You could have maybe height, address. You could have all kinds of spouse information. These are just a few examples here that the parent has. And then the methods are tasks that the object can perform. So in this case, the methods are read bedtime story, drive in a carpool, maybe make breakfast could be one, change the diapers, all kinds of stuff that could be set up as methods. But it's all contained in one object. And an instance is an example of a specific object. So Mary Smith is a parent, so that's an instance of an object. Ahmed Ali is also an example. Anthony Green, another example. So these all are instances that represent the parent object. Here we can see the same kind of idea, except this time it's a child object. But the attributes and methods and the layout of the object are going to be the same. The instances would be individual children. These are the different methods. I'm sure there's a lot more we could come up with other than this. But this is an example of a child object. Here is an example of a dog object. So they can wagtail, eat, fetch, sleep. Attributes are characteristics of the object, like we've said. So here's some examples of some attributes. And they can have many, many attributes. This would not be enough if this was a real student information system. However, attributes are the characteristics that describe the object. Here's an example, here's an example of a fitness class schedule object and a registration record. These are both objects. So methods are specific tasks that an object can perform. And here is some methods for add student. Let's look at this one here. So there's add a new student instance, record a student number, record a name, save new student data. One thing I can see that's not on here is a method for student name change. If a student gets married or something like that, that could be a method that would be necessary. So specific tasks that can be performed. Messages are the command that tell an object to perform a certain method. The same message of two different objects can produce different results. This is known as polymorphism. So you can view an object as a black box. Message can trigger a change in an object without specifying how the changes must be carried out. Here, it's right here, it gives you a gas pump example, but let's take an example with a clock. So let's say you have a command that says set minutes 20 ahead. So that's a command that you could send to a clock. How do the gears inside that clock work so it changes the time, so it moves the hand? Who knows? Who cares? That's the black box aspect we're talking about. With encapsulation, all data methods are self-contained. And here's an example of that with instructor and student record. So here's an example of sending the same message to three different objects and getting a different result. This is the polymorphism example. And here you can see you send goodnight to the parent, causes the parent to read a bedtime story, dog will sleep, child will get ready for bed, what have you. Let's go over classes now. An object belongs to a group or category called a class. All objects within a class share common attributes and methods. Subclasses are objects within a class. For example, a truck object represents a subclass within vehicle, along with other subclasses, maybe car and school bus. A superclass is a general category. A novel class belongs to a superclass called books because all novels are books. So that's an example of how classes are named and how they're subdivided. So here are some examples that you can look at for yourself here. We've gone through all this stuff already. So in this example, we'll show that the person can be any person. That's a superclass. And employee is this class. And instructor is a type of employee, so that would be a subclass. That's the example this slide's trying to display. Here, let's go through relationships amongst objects and classes. Relationships enable objects to communicate and interact as they perform business functions and transactions required by the system. They describe what objects need to know about each other. describes how objects respond to changes in other objects, and the effects of membership in classes, superclasses, and subclasses. The strongest relationship is called inheritance. Inheritance enables an object called the child to derive one or more of its attributes from another object known as the parent. Let's take a look at an example of this here. So in this example here, we have two classes. We have the employee class and we have a subclass as instructor. So an instructor is a type of employee, so that's why it's a subclass. It's also referred to here as the parent, and the instructor side is referred to as the child. So the instructor might have some information like classes taught, degrees earned, what have you, on the instructor class object. But what about on the employee side, the social number? Why wouldn't you have that with the employee and the instructor? Well, because it's redundant and we don't want redundant data. Therefore, we use what's called inheritance, where the child inherits from the parent. Here's an example of an object relation diagram. It shows the objects and how they interact to perform the different business functions and transactions. So as you can see, this is a very high level explanation diagram. Object modeling with the UML. UML uses a set of symbols to represent graphically the various components and relationships within a system. It uses case modeling. Steps in a specific business function or process. An internal entity called an actor initiates a use case by requesting the system to perform a function or process. And this actor term, you might be comfortable with this or have heard of this from one of your sociology classes. It's the same idea there. UML symbol for a use case is an oval with a label that describes an action or event. An actor is shown as a stick figure with a label that identifies the role. So you can see some examples here. So in this example, when a student adds a class, Produce Fitness-class roster uses the results of add class to generate a new roster. When an instructor changes his or her availability, update instructor information uses the change availability use case to update the instructor's information. So here you can see that going on right here. Here we have an example of the add new student use case description. It documents the process used to add the student to an existing class in this case. So it gives you some of the different descriptions and conditions that exist here. Use case. What is it? Visual system. Step. Identify the system boundary, which is represented by a rectangle. This boundary purpose is to identify what is included in or what is outside is not the system and what's not. So in this example, we can see this is an auto service department, and this boundary represents people are the object into with root creation. Class diagrams. These show the object classes and relationship involved in a used case. Each class appears as a rectangle with the class name at the top, followed by the class's attributes and methods. Lines show relationships between classes and have labels identifying the action that relates the two classes. The diagram also includes a concept called cardinality, and this describes how instances of one class relate to instances of another. Here we have UML notation indicating the nature of relationships, and these relationships can be 0 to many, such as an employee, to payroll deduction. An employee can have no payroll deductions or many payroll deductions. The employee-spouse relationship should be a 0 to 1 relationship, meaning they can have no spouse or one. I'm sure there's exceptions in some parts of the world, but here in Connecticut it's a 0 to 1 relationship. Next, you have an office manager relation to a sales officer. An office manager manages one and only one office. That could be a different scenario, but in this case that they're making this example, that works. And one-to-many. An order can be included in one or many orders items. You can have more than one item on one order is what that's saying, or it can be an order with just one item. But it can't be zero, so that's a one-to-many relationship. Here are some examples of that with the class order use case. And you could have the attributes and methods listed here. It would make this a little large to fit on the slide, so it's been omitted. Sequence diagrams. This is a dynamic model of use case showing the interaction among classes during a specific period of time. Graphically documents the use case by showing the classes, the messages, and the timing of the messages. It includes symbols that represent classes, lifelines, messages, and focuses, and we're going to go into that. Classes are identified by a rectangle with the name inside. Class 1, Class 2. Classes that send or receive messages shown at the top of a diagram. It's identified by a dashed line, so right here. The lifeline represents the time during which the object above it is able to interact with the other objects in the use case, and an X marks the end of a lifeline. Messages identified by a line showing the direction that runs between the objects. The label shows the name of the message and can include additional message information about its contents. Focuses, identified by a narrow vertical shape that covers the lifeline. The focus indicates when an object sends or receives messages. So you can see the examples right here. Right here we have an example of the Add New Student use case. This is an example of a sequence diagram, and you can see how it's all laid out here. Next, we're going to look at a state transition diagram, and that's what one of these looks like here. It shows how an object changes from one state to another depending on events that affect the object. All possible states must be documented in a state transition diagram. States appear as rounded rectangles with state names inside, so these are the names right here. And just take a second to look at the state transition diagram. Next, we're going to look at this right here. This is a step-by-step diagram. This is known as an activity diagram. It shows the actions and events as they occur. It shows the order in which the actions take place and identifies the outcomes. BPM, or Business Process Modeling, is represents the people, events, and interactions in a system. Remember, we talked about the rectangles. So outside rectangle is called a pool, and designated swim lanes show specific actions and events. Swim lanes can interact when certain events occur. And here's some examples of the swim lanes here. I'm not going to focus on this slide too closely. Case tools. Object modeling requires many types of diagrams to represent the proposed system. Creating the diagrams by hand is time-consuming and tedious. Case tools speed up the process, and they ensure consistency. Next, we're going to talk about organizing the object model. An object relationship diagram that provides an overview of the system. That's high level. Organize your use case in use case diagrams so that they can be linked to the appropriate class, state transition, sequence, or activity diagrams. It is much easier to repair a diagram than to change the software later. That's very true. Now we'll go through the chapter summary, and I will let you look these over for yourselves.